All right, guys, we're going to go ahead and do slides 11 through 15 today. So remember, if you're opening up your review and it says view only, you can go ahead and fix that by unsubmitting it from yesterday's assignment or from Monday's assignment. So if you submitted it yesterday on Monday, you can go ahead and unsubmit it and it will let you edit it. Okay, so how do earthquakes change Earth surface? So we have some images over here. These images go with earthquakes. So as you can see, before an earthquake and after, there's a lot of damage to the buildings. And then often earthquakes can even cause small or even very large cracks in the earth. So buildings are damaged and cracks in the earth. All right, and then how do volcanoes change Earth surface? So there's several ways here. First off, it can change the shape of the mountain. By a lot of times when volcanoes erupt, they'll actually blow off bits of the mountain whenever they erupt. And so what happens is they'll make the mountain smaller or kind of take off the peak. And then here, this is showing you that lava is coming down this land and it's reaching the ocean. So this is before and then this is after, and you can see how much farther out the lava comes. And so one of the things that volcanoes do is create new landmass, and that's because they're spewing this lava, which is melted rock. And when that rock cools, it's creating new landmass. And so a lot of islands are created through volcano eruption. So before and after, you can see there's a lot more land surface here. And so over time, this land surface will be repopulated with plants and animals, and it will be a larger island because of that volcanic eruption. So we're going to go with new landforms and mountains we'll just say lose their top. Okay, so go ahead and pause this video if you need more time to type. All right, moving on to 12. So now we're reviewing sedimentary rock formation, and so here's a diagram, and we're just going to drag the labels to where they go. So remember, when sedimentary rocks form, it starts with the layers, with depositing sediment into layers, and so that happens over and over millions of years, and more sediment is being deposited all the time, and so it creates those layers, and as those layers build up, you create a lot of weight and pressure down below, and so all that heat from inside the earth and the pressure from all those built up layers causes compaction and cementation, and then we have a sedimentary rock form. So first step would be not cementation. Let's see, layers form, more layers pile up, eroded sediment. So here is the first step. So eroded sediment ends up in the water and settles to the bottom. Then let's see, more layers, or with time layers. Okay, so we're going to go with more layers form. More layers and further compaction force out water from the layers. Oh, wait, no, actually that might not work there. Hold on. Let me read these all the way through. Okay, so actually compaction would go here, because we're not ready for the water to be forced out yet. So as time passes, more layers pile up and they start to press down on those bottom layers. Then even more layers build up over time. So layer upon layer upon layer, causing lots of compaction, lots of pressure, but also it is forcing. So in the case of when the sedimentary rock forms under bodies of water, the pressure from those upper layers actually force water out of the layers. And what's left behind is the minerals, which act like a glue and cement the layers together. So salt crystals glue the layers together, rock mass is formed. All right, 13. Okay, so we're going to go with this picture first. You have it's showing increased pressure on this on these layers of sediment. And then if you look over here, now they are much smaller. So what process is being illustrated here? That would be compaction. Remember, compaction is a process that occurs during sedimentary rock formation. It happens because of increased pressure because of a lot of weight pushing down on layers of sediment. And all that weight squishes them together and makes them smaller. Remember that compact means small, and so compaction is the process of making something smaller. Now we're going to list very short and sweet the steps to sedimentary rock formation. So first you have weathering, erosion, deposition. And we're just going to add layers. Oops. We're going to add layers next to deposition. So layers start to form through that deposition. Then the more layers that build up, those put pressure on the bottom layers. So there's pressure from the layers and heat from inside the earth acting together to form a sedimentary rock. So we have heat and pressure. We also need millions of years to pass. And over millions of years, that heat and pressure is going to cause compaction and cementation. And I will tell you that a lot of times you're going to be asked to compare sedimentary rocks with fossil fuels. And so one thing that they have that's in common would be these first three. They both require heat and pressure. They both take millions of years. They both happen because of weathering, erosion, and deposition. A big difference is that we don't use the words compaction and cementation to describe fossil fuel formation. Compaction and cementation are usually reserved and only used to refer to sedimentary rock formation. All right, slide 14 and 15, we're going to look at fossil fuel formation. So here we have how coal was formed. Remember, coal forms in areas where there used to be a lot of plant life, where the earth was covered in swamps. Those plants die, become buried, and over the course of millions of years, they get pushed deeper and deeper into the earth, and over millions of years, all the heat and pressure that they were exposed to turned them into coal, which is a solid fossil fuel. It looks a lot like a rock. We mine it out of the earth and we use it for energy. So before the dinosaurs, ancient plants died in the swamps that covered the earth. Over millions of years, the plants were buried, and heat and pressure turned the dead plants into coal. So how is coal formed? Ancient plants die, get buried. Heat, pressure, millions of years. And actually, we don't need 5. We could have made, we can make buried its own step. There we go. All right, and the main difference between coal and oil and natural gas formation. Coal is from plants. Oil and natural gas is from ocean organisms. All right, that was a lot of typing. Make sure you pause the video if you need to catch up. And slide 15, we're going to look at petroleum and natural gas. So petroleum is just another word for oil. So whenever you see petroleum, think oil. They are the same thing. Petroleum is just a specific term for oil. So we have another diagram. So petroleum or oil and natural gas were formed where there were oceans. So millions of years ago, okay. Oh, you know what, guys? I just realized that there is a duplicate here. See, this one and this one are the same, which means we are missing the card that goes here. So here's what you're going to have to do. Grab that one and delete it. Then you're going to do your text box and just draw one real quick. And we will just type in. So we're just going to keep it short. Ancient ocean organisms died and settled on the ocean floor. So take a minute to do that. I just grabbed a text box and I typed it in since we are missing the card for that picture. Then, over millions of years, the remains were buried deeper and deeper. Heat and pressure changed them into oil and natural gas. And today, we drill through layers of sand and rock to reach those deposits. So, ancient ocean organisms die. That's first step. Organisms are buried. And then we have heat, pressure, over millions of years. And then we are just going to drag the circle to answer the question underneath about Midland. Let me make this a little bit smaller so it fits. Okay, Midland, Texas has oil and natural gas deposits underground. This is because Midland was. Okay, so what can we conclude? If Midland has oil and natural gas deposits underground, so if there's oil and natural gas there, that means that at one time, Midland was underwater. All right, and that's it for today.